Ross, and today we're going to do vector valued functions. Now I'm going to set up some basic parametric equations, and while I'm doing that, I'll run your colors across the screen. So here we have two basic parametric equations. They're set up separately, but you can combine them into one equation in terms of y or x. However, if you want to combine them and keep them in terms of t, you can do this. Using the unit form of a vector, you can set the coordinate equivalent to a vector instead of being two separate points, each dependent on the same t variable. Now you just have one function. And it works like this. In a regular graph, you have your point and it's not attached to anything. In a vector valued graph, you do have your point and you have your graph, but it's all traced out by vectors. So a circle is actually a bunch of vectors going to the endpoints. Alright, now that we've done some pretty basic groundwork, it's time to do something more interesting. Now, just like regular functions, you can derive these. And so, let's say r of t is sine of t I plus cosine of t j. Well, r of t is actually f of t I plus g of t j. So r prime is actually just f prime plus g prime. So r prime in this case is cosine of ti minus sine of tj. Alright, and so since vector valued functions are a happy little parametric equation or a set of them described as a vector, the same thing works for smoothness, except when it's smooth, you've got your r of t over r prime of t to tell if it's smooth, meaning that even if the y component is 0, if the x component isn't, it'll still be smooth because r of t is one function as opposed to two, making it much easier to deal with when you're doing parametric equations with these. Now, let's move on to something less derivative. It's an integral. If you take the integral of r of t, it's the same as taking the integral of f of t plus the integral of g of t. So all the same rules apply. It's pretty simple, but vector valued functions can be applied in one more place that parametric equations are. And that is velocity and acceleration. And really, when you use vector valued functions for these, you're just using it instead of to have two functions that you gotta derive and two positions you have to find. You just use it to have one set of a function to derive and integrate and all that for velocity and acceleration. Happy calculus, and God bless. I've been Bob Ross.